Okay, so we talked about HTTP request and HTTP response. We also covered the fact that HTTP doesn't necessarily transfer text content in the sense that binary content is going to be transferable via HTTP, but it's going to be transferable by being encoded to text, right? And it's a base64 encoding. And something to note is that whoever has an HTTP resource has to specify its type, and the type is something called the MIME type. There's a list of these. They initially came from email attachments, and they are specified via a header which is called content type. Right? So if I, for example, if I want to save an object on the server, I'm going to have to specify what that object is represented as, be it XML or JSON or whatever it may be. Now, we also talked about the fact that the protocol is extensible in the sense that apart from the, let's say, the minimal HTTP request, which is a request line specifying a method and an address, and then an empty line, and then the optional request body, then I can have a number of headers, right? And the headers are key value pairs. We can easily see them, right? So if I press F12, one sec. Let me reshare the whole thing because you're not going to see my my actual window or screen. Right. So if I press F12, which are the web development tools, I can actually see in network what's being transferred. In this case, it's my little server. And if I go here, I can see a series of headers. Right? In this case, they're caching headers and so forth. But these allow me to customize the way that HTTP works. See, I sent a header which says, well, what I'm prepared to accept is some HTML in various forms, and the response has a content type somewhere around here, which tells me that it has delivered HTML. Right. Another thing we saw when we looked at response codes was the idea that HTTP, one of the response codes for HTTP is a redirect code, right? And the redirect code is specifies the fact that the server doesn't have that particular resource, but it knows where I can get it. And one specific case of this is client-side caching. Right, that the redirect mechanism is involved in various things I can do over HTTP, one of them being client-side caching, but various forms of caching. Because think about it, if you want to access a resource, the server might tell you, well, I'm not ready to generate this resource, mostly, but I know somewhere where you can get it. And this is how caches for, on the one hand, how the cache on your computer works, right? Because the server is going to tell you, I'm not ready to give you the resource, but you already have it. It's a redirect to yourself. Secondarily, though, let's assume that we have some sort of processing which takes a long time. Now, if the situation that created the results didn't change, the server might tell me I can find the result in a cache. And that's how a query cache, for example, works. Okay. So that's redirect. Redirect can also be used for various other things. For example, if you look at all the blogs shilling all the different products, they have to be paid somehow. And the way they are paid is you have to establish a relationship between the user getting to the product and the fact that they came from that particular blog. And the way this is done is the link on the blog doesn't actually go to the product. It goes to a redirect affiliate hub, let's say. And that hub remembers that the user passed through it, and it remembers the user ID. And it's in relation with the store, and then the store knows that that particular user came to the shop from that particular blog, and they can pay them. Right. What else do we have to discuss here? Well, one thing we're going to use over HTTP is RESTful services. Now, it's not a standard or a protocol per se. It's more a list of rules, and it refers to solving a difficult problem, which is remote object access, through a simple mechanism, which is only the things contained in HTTP. And this is going to be done via a limited vocabulary, in the sense that the verbs, let's say, I'm going to use are going to be the HTTP methods, And the URLs are going to identify what the structure of my object landscape, so to speak, is. We're going to go over RESTful services when we're going to write our own more in detail. But this is something to take into account. Now, what we're going to transfer via these services is going to be something which is called JSON. Now, JSON is JavaScript object notation. And what you have to take into account here is that JavaScript was invented as a language for the web. Right? And since it's a language for the web, it's really easy to serialize and deserialize objects, because the assumption is they're being transferred somehow. So one of the native representations of JavaScript is this serialization format, which is called JavaScript Object Notation, which is a really simple format. Now, this assumes we're taking a different perspective on the problem, because before this transferring JSON over the network, what we used to transfer was XML. And XML has a lot of additional stuff you have to transfer and to process. Right? So for XML, in order to access objects via XML, and the protocol was called something, it was called the Simple Object Access Protocol, you have to get the type definition for everything. You have to get a method definition in the sense that the verbs, the things you can call on the server, are not limited in scope. Right? So you can use any kind of verb. And because of that, you have to have some sort of discovery mechanism, something to ask the service, how can I call your methods, right? How can I access your content? And this is done in a different language, which is called the WSDL. And the whole thing transfers a lot of information over the network, and is really complicated, which is where transferring JSON over RESTful services came from. It's a way of simplifying the interaction, and both from a technical standpoint, what I'm transferring, but also from a logical standpoint, right? It's a lot easier to understand. Now, that does not mean I might have situations where I have to access objects which are exposed, for example, by a third party, right? They're not in my code. It's an application written by somebody else. And in this situation, I might want some of these complications, such as I might want to check if the objects I'm getting respect a particular schema. They have particular types, they have a particular shape. And I can do that over JSON, but I'm not obligated to do it. Right? I can use something like JSON schema. For example, NextLab does do this. Right? So it does validate JSON, so to speak. But I can also write something which is really simple, where I have no validations, I have no type specification, and I just access the objects. And this is going to work fine for an application which doesn't interact with external sources, and as well as for an application which is relatively simple. All right, so it's simplifying the web. Now, something else to take into account is that what we've basically been talking about is HTTP 1.1, which is the longest running version of the protocol. But lately, well, relatively, HTTP 1.1 was succeeded, not necessarily succeeded, because the web is made out of these incremental adoptions, right? So not everybody supports any particular new version of a protocol. But the idea is that Google had an internal protocol which it used between its own applications, and it managed to impose it as a standard. And that's HTTP 2, and then HTTP 3. Now, HTTP 2 is based on something called SPDY, so SPDY. It's a binary protocol, and think about it, aside from the other features, it's making HTTP binary and extending, making it secure, and extending compression mechanisms to the whole request. Now, I've mentioned that through the headers, I can actually enable compression. So I can ask a server to send me the content it's willing to deliver in a compressed form, so that the communication is more effective, right? Because if you compress text, it's really efficient, right? Text has the most efficient compression rate. It's most advantageous to compress text. Right, but that compresses only the body of requests, and HTTP 2 also compresses the headers, and it compresses the method, the address, etc. It also compresses them at connection level. What does that mean? Well, initially, when HTTP was invented, what happened was each of my HTTP requests was a separate connection at a lower level, right? So I connected to the server, I got my resource, I closed the connection. Now, this is really ineffective, because creating and destroying so many connections is really, really resource consuming. So the first thing that came about was that I had connection keep alive, right? So that means I reuse a connection, but I reuse it on the server level. The user doesn't actually know that it's being reused. Now, so HTTP 2 does this whole compression scheme over all the things sent on a particular connection, which is again a source of efficiency. Then there's a couple more mechanisms. So we talked about HTTP and we mentioned HTTPS, and we said that these two protocols are identical, right? So they have the same commands. The only difference being what they're using under them to actually transfer the data. So HTTP uses TCP, which is a clear text protocol. You can read what's in it. Whilst HTTPS uses TLS, right? So transport layer security, which is something which is actually on top of TCP, but actually encrypts the data. So the intention for HTTP2 was for all the data on the web to be transmitted securely. This didn't happen. However, so in theory, this whole all traffic is secure isn't a part of the standard. But in practice, all the implementations of HTTP2 mandate secure connections, so to speak. So you have to have transport security. Something else which appeared in HTTP2 is something which is server push. Right? So the server, on the one hand, the server can send multiple requests, multiple resources. Now, the way it worked on HTTP is you request a resource, you get the resource, you read the resource, you see what else the resource needs to be displayed, you request those things, and so forth. And you wait for each of them. Now, on HTTP2, this can be done progressively, which means I can request multiple resources at the same time. The server can deliver them based on some priority, and it can deliver the chunks of each resource interspersed, right? So it doesn't have to deliver the full resource 1, then the full resource 2, and so forth, but rather in any order. And the server can do server push, although this bit is a bit more unpopular. What server push means that the server, without you requesting an additional resource, the server knows you're going to need it, and it sends it to you preemptively. Now, so that's the gist of HTTP2. HTTP3 is based on another Google protocol, which is called QUIC, QYEC, QUIC, and this is rewriting HTTP over UDP, right? So I said that the difference between HTTP and HTTPS was that below them they used a particular protocol to send their data. Now the typical two protocols that exist on this layer, which comes under the application layer, are TCP and UDP, right? Transmission Control Protocol and User Datagram Protocol. Now, Transmission Control Protocol is a protocol which gives you some assurances about the traffic being transmitted. For example, if you send a packet in the network, what's going to happen is you don't necessarily know if it reached its destination, right? So TCP has mechanisms to confirm, for example, packet reception. And a bunch of other things like this, which relate to reliability of transfer. Now, this means, however, that the protocol is relatively heavy. So there's thinking about the efficiency, the transfer efficiency of a protocol. So I have my data, and I'm adding some additional information for the transfer to be possible, right? And the proportion between my data and the full size I'm transmitting is the efficiency, the transfer efficiency of the protocol. Now, UDP is a protocol which doesn't have any of these assurances, which means it's a lot more transfer efficient. However, it wouldn't work in a web setting, which means you have to, at your application level, you have to basically reinvent some of the features of TCP, the ones you felt you needed. So what QUIC does is it reinvents these, and it passes HTTP over UDP. Theoretically, this should lead to something a lot more efficient. This is not necessarily true in the real case. However, HTTP3 does have a relatively larger adoption rate. So it's adopted a lot more quickly than HTTP2 was adopted. And I think we're going to stop here with HTTP, and we're going to go to our JavaScript discussion. Do you have any questions up until this point? Okay, so we're going to continue with JavaScript, and the reason why we're starting with JavaScript is this is the fundamental language of the web, and the sooner you get into it, the sooner you're going to be able to write your own code for the web. Let me just find it. Right, obviously we start with the hello world. this is going to print something to the console. Now, something interesting about JavaScript, like I think I mentioned, is I can test this, right, at any point. If I'm going to copy paste this thing, press F12, and here in the web tools, I have a console, and I can run it. Right? So I can do this at any point. I can go to, I don't know, Google's website and put a breakpoint in Google's code, basically, because that's how the web works, right? Because all this runs on my computer, right? So the client-side code is client-side; it's on my computer. So I can actually breakpoint Google's code and investigate. Now, Google's code is A, somewhat complicated, but B, it's obfuscated. So I do need some level of skill to be able to make something of this. I mean, to actually understand something. I can put a breakpoint really easily, but what that means, I have to put in the effort. Now, this short snippet is still relatively interesting because, on the one hand, I see something which I might encounter in many languages, which is I have a string literal there, which is hello world. And it's it's enclosed within apostrophes, right? Single quotes. And this idea exists in many languages. That is, I can do string literals either between single quotes or double quotes, or maybe something else. And the reason for this is to avoid escape sequences, right? It's if I have to have an apostrophe into something, and in something, I'm just going to enclose the string between double quotes, and the apostrophe is going to be ignored. It's just going to be another character. Now, but what is more interesting here is that if I look at this, it seems to be calling a method on an object, right? It's console seems to be an object, and log seems to be a method which receives a string as a parameter. Well, but I have to wonder, where does this object come from, right? Because I didn't actually declare any sort of console. Well, the idea is that the JavaScript interpreter has some global objects. Now, these global objects are automatically instantiated. Right? I have them, I can use them without doing anything else. But another interesting point is that these objects are different depending on what kind of JavaScript I'm using, so to speak, so the context. Right? Because I have server-side JavaScript, I have client-side JavaScript, and obviously in server-side JavaScript I'm going to have other objects than I have in the browser, because if I think about the browser, there's some stuff I can assume is there. Right? What is there? Well, I'm in a window, right? So there's a global object called window. Well, the window is in a browser, so there's a navigator, and so forth. I'm rendering an HTML document, and so forth. So there's a bunch of global objects. We're not going to go deeper than that right now. But if I think about running JavaScript from the command line, obviously, maybe I'm going to create a window, but I cannot assume a window. Maybe it's there, but possibly it isn't there. So I'm not going to have this, but what I am going to have is I'm going to have specific stuff to running something in the command line. For example, I'm going to have information about my process at the operating system level. Now, on the other hand, I can't have information about my process in the browser, because in the browser, since you're downloading code written by somebody else and running it on your own computer, there have to be some limitations. That code has to be sandboxed. It cannot have unfiltered access to your processes and files and so forth. So you can't have that. The APIs I'm going to have access to also reflect this, right? Because there isn't anything in the browser for which I can say, well, I'm going to give you this path, and you give me a file descriptor, and I'm going to read from that file, right? Because that would involve having access to the computer of the client. And there would be a lot of inventive applications for this, right? You download some foreign code and you run it on your computer. It would create some comical consequences. Right. So let's talk generically about JavaScript first. So it's a multi-paradigm language. What that means is I can write code on various models. These are not all the models. If I were to go deeper. But you've encountered a series of models studying other languages, right? So if I think about imperative programming, what is imperative programming? What would that mean? You have control structures. So it's not necessarily imperative, yeah. Yeah, you have control structures, right? Because initially this was an innovation, right? Not writing code in assembly style. Then I have object-oriented. Obviously, this means you have objects. We're going to go back to objects a bit further, and then I have functional written here. There's also an asynchronous paradigm, but we're going to talk about that later. What would functional mean? What would saying that a language is functional entail? What does that mean? What do you think? Let's try to explore it together. No wrong answers and stuff. It is what? Sorry.
It uses a lot of functions, not objects.
Well, all languages use functions. if you think about it, right? So let me put it this way. So if you look at C, right? C uses a lot of functions. Your entry point is a function. Everything is functions. But C is not a functional language, for example. Right. So the idea is the core thing for functional languages is functions are values. Right? What does functions are values mean? Well, intuitively, it means that whatever you could do with an integer, for example, you can do with a function. Right? Can you store an integer in a variable? Sure, you can store an integer in a function in a variable. Can you have an expression which evaluates to an integer? Then you have to have that for a function as well. Can you send an integer as a parameter to a function? You know, you get what I'm saying. I mean, they're values just like any other value. And this has some interesting consequences. Now, interestingly, languages are, in time, languages converge, so to speak. So initially, in something like Java, you didn't have any functional core. There wasn't anything which is functional-like. But in time, what happened is it started as an object-oriented language primarily, but you had functional characteristics added on. And if you think about collection streaming APIs, right, where you have lambdas, those are an element of functional programming. Same for C# and so forth. Obviously, JavaScript started out as a functional language. That was the intent. Now, we're not going to go, we're going to see some functions, but we're not going to go really deep into this. We're going to talk about it next time, what this functional idea actually means, right? It's an interpreted language, which means I'm not going to compile my code, right? It's just going to be my text. It's the source code, and I pass it to the interpreter, and the interpreter interprets it. Now, this again is in time. It's become not actually that clear because the interpreter can do just-in-time compilation, right? Which means it's going to take pieces of code and just, without me doing anything, it's going to compile that thing in memory in order to get it to run faster. Now, JavaScript has dynamic types which are determinable and modifiable at runtime. Now, this is going to be the start of the JavaScript trip, so to speak, in the sense that in JavaScript is more dynamic than anything dynamic you've encountered until now. In the sense that typically when I talk about dynamic typing, what that means is at line 10 in my code, something can be an integer, and at line 12, it can be a string. So I can reassign types, and the way I determine types is if a variable contains a string, it is of type string. But if incidentally it contains something else, it's of that type, right? And I can change this at any point. But JavaScript is even more dynamic than that in the sense that I can change the significance of the types themselves. That means, let's say I have a string, I can redefine what a string means. Right? Instead of changing the type of a variable, I can change the nature of the type. Right? And we're going to see this, and it's I can actually modify core types. Right? So I can modify the string type. Now, this is not necessarily a good idea, but it's part of the feature set of the language. Now, it's initially client-side, like I said, and this is reflected in the way the language is constructed. If you think about it, JavaScript was invented in order to automate graphical user interfaces. And so it answers the typical challenges for this use case, right? Because if you think about computer programming languages, you can have truly generic languages, and truly generic languages are just as bad for solving any problem. Right? They're none better to solve any particular problem. Or you can specialize your language somewhat, and then it's going to be a lot better to solve a particular problem, but it's going to be maybe not that great to solve the other general problems. All of these languages are Turing complete. They can solve all solvable problems. But JavaScript is optimized basically for a particular use case. Now, incidentally, that use case fits both on the client side and on the server side. Because on the client side is graphical user automation, user interface automation, whilst on the server side, the use case is processing a bunch of requests, processing as many requests as possible. Because that's what the server does. It receives requests from the customer, from the clients, and it replies to them. So that means JavaScript is not optimized for writing compression software, a bit of compression software, but it is optimized to answer HTTP requests, or really any kind of network request. Right, it's fundamentally asynchronous. Now, what does this asynchronous business mean? Well, getting back to our graphical user interface idea, right? If I have a graphical user interface, I'm going to run into let's say, fundamental and known problem, which is, let's say I write a window, I write an application which has a window, and in that window, I'm going to load an image. And I select an image from the hard drive or whatever, and the image is really large. Right. So how can I think about this operation? Well, I can think about it in two ways. The first way is I'm going to wait for the image to load. Right? Now, but if I wait for the image to load, that means that loading an image is synchronous. That means it is blocking. So if it's blocking, that means my application cannot do anything else in the meantime. If it can't do anything else, and I have a single threaded application, what's going to happen is the application is not going to be able to redraw, which means it's going to give me the sensation that it's actually crashed. So the solution for this, because it's not like there's no solution, the solution is to have a multi-threaded application, to have multiple threads, and to have a dedicated thread where I can pass long-running tasks. Right? I can load that image, run that query, make that web request, whatever it is. So I don't have to wait for it, whilst my main thread is going to continue to repaint. Right, the second way I might think about this is asynchronous, which means whenever I start a task, I assume that I'm not going to wait for it. Right? It works like this multi-threaded example by default. Right? But my problem is, what happens if at line 9, I start a long-running task, and at line 10, I need the result? What do I do then? Well, I need, it's the same problem, but it's reversed, in the sense that the challenge now is going to be to have a mechanism to wait for my results, if needed. Make sense? Right, so JavaScript, you have these two options, right? Traditionally, for example, C# is synchronous, but JavaScript is asynchronous. It's how you look at it. Because if you write a Windows Forms application, for example, although C# actually has a sync await in the meantime, but traditionally what you do is you load that image on a background worker, right, which is a separate thread actually. Here you just start loading the image and the program continues to execute to the next line, and that's it. And you have to have some mechanism to know when the process of loading an image has finished. Now JavaScript uses the Unicode character set. This can be funny or practical. Funny means you can write variable names with special characters, but obviously your objective should be to write maintainable code, not unmaintainable code. But the advantage for this is when processing stuff like strings, you don't have to have any special assurances to work with, I don't know, the extended character set of the Romanian language, for example, right? You can write ts and sh and whatever. Without anything special. It's case sensitive, but that's relevant. Now, both something to add here is that both the client side and the server side, let's say flavors of JavaScript, work on an asynchronous model. They're both based on this asynchronous model, which means we're going to have to wait for the result for our processes explicitly. One sec. Right. So let's see a couple of things about JavaScript. So something I didn't mention is I said that JavaScript is an object-oriented language, or it contains an object-oriented paradigm. Now, there's the idea of a purely object-oriented language. Now, a purely object-oriented language, like Python, is a language in which everything is an object. Now, a trivial consequence of this is you can't have primitive types. Right? There are only objects. You can only access objects for what you'd think about as primitive types, such as integers. Right? Integers are objects, strings are objects, everything's an object. Now, JavaScript is not purely object-oriented in the sense that it does have primitive types, although in most cases I can ignore this. The reason why I can ignore this is that my primitive types are auto-boxed. Do you remember what auto-boxing is? Right, so in Java, for example, if I add an int, a primitive int, with an integer object, I just put a plus between them. Does that work? Yes, it works. How does that work? Well, it works because the int, I can't actually add this. Right? It is not possible. They're different types. But the int is actually auto-packaged. There's an object created around it to be another integer. So I add the object representations, the object representation of my int and my integer object, and I get an integer object. Make sense? This is called auto-boxing. Another case of auto-boxing is, for example, I have something primitive. I have a primitive, a string literal. And on that string literal, I call a method. Now, obviously, the string literal doesn't have a method. However, this is generally going to work because the primitive is going to be auto-boxed automatically by the language in a string object, and that one does have the method. Right? So that's the auto-boxing bit. Right, we've gone on a tangent a bit, but so JavaScript is not a purely object-oriented language. However, it's let's say it's a lot more object-oriented than you expect. In what sense? Well, things which would be abstractions in other languages are actually concrete in JavaScript, and their representation is an object. Let's take the most insane example possible. Well, let's go for so an array is an object, a function is an object, a library is an object in JavaScript. But so these are objects for which I can get a reference. I can have a variable containing a module, a library. However, most of the other things are concrete and they're organized in an objectual fashion. In the sense that, for example, namespaces are objects. Now, they're objects I can't get a reference to, and I can't actually have a variable containing a namescape, but the internal representation is objectual. Now, maybe we should talk about what an object is. Let me pass through the first answer that doesn't apply, which is an object is an instance of a class. There are two types of languages which support object orientation, one of which is called a classic language in the sense that it has classes, and one of them which is a non-classic language, right? The two categories. The only mainstream language which is non-classic is JavaScript. Right, so JavaScript doesn't have classes, although we're going to get into some confusion later because it does have a keyword called class. But it doesn't have classes, so it's not represented in that fashion. So considering that in JavaScript an object is not an instance of a class, what would the definition of an object be? Well, think about a more generic definition of an object. It's a data structure. Yeah, that's a bit too generic, but it's on the right path. So the second answer, which you might, yes, that's closer, right? So because an object is a way of grouping characteristics and behavior is methods. Because if you think about, I don't know, I have a cat object, right? All cats have a color, although the value of the color is going to be different from cat to cat. But all cats meow in, let's generalize, all cats meow in the same fashion, right? Which means they have some common behavior, which is meowing, and they have the existence of some characteristic, although the value of that characteristic is different. Make sense? But let's go even more general, and then we get to what you said, which is the data structure answer. Which is, but what happens in this case if I'm in a functional language? Well, in a functional language, I said functions are values, right? Which means there's not actually that much of a difference between the color of a cat and the meowing of a cat, as long as the idea of meowing is something which can be used as a value. Which means I get to the point where my objects are actually just list of key value pairs. Right? So they're hash tables, more or less. But some of the values of the keys are going to be strings, for example, like the color, or whatever the color is represented as, whilst some other values are going to be functions, and that's the behavior. Does this make sense? Right, so an object is a list of key value pairs. We go through it again. And the keys are just names, right? Whilst the values, they may be primitive types or object types, or they may be functions. Now, the key is just a name. The key is meow, in this case. right? So the key is meow, and the value is whatever my functional representation is. It's something which represents a function. Let's not get too deep into that, we'll get back to it. But, right, so I said that functions are values, which means there are some expressions in the language which actually evaluate to a function. Just like I could say int I is 1 plus 1. 1 plus 1 was an expression which evaluated to an integer in this case. Just like that, I can have some sort of expression which, when evaluated, returns a function. If you want a hint for this, you've done this in Java, so that sort of lambda thing which you can send to a map, for example, that's a functional expression. It's something which evaluates to a function. Make sense? Now, if you're here, let's make another step, which is, what's the difference between a function and a method? If I can move functions around, what does a method know? A method knows something. It knows a reference to the particular object it's on. So it knows who this is. And in JavaScript, I can actually have functions, just a function, and I can actually, let's say, bind it to an object and give it a this. So this whole thing is pretty mobile. I can transform a function into a method into a function, and so forth. I can pass it around. Again, we're going to see. Now, what we wanted to see here, though, is a bit different. So, in JavaScript, I can define variables in two fashions, right? I can define them. So I can define stuff, first of all, with var, let, or const. Now, const is somewhat self-explanatory. It's if you reassign the value of a const, you're going to get an error. That's what a constant is. But var and let, well, the difference is a bit more subtle, and we'll go into it more next time. But it's interesting to think why I have two ways of doing it. Well, I have two ways of doing it because the semantics of var are a bit strange. Right? It does something which many languages don't do. So at some point, they wanted to create a mechanism in the language to have the regular semantics you're used to, right? Which is, when you define a variable, it's going to be visible here. However, the web is alive, right? Which means there's a website somewhere out there for somebody who sold, hand-colored carpets, which has some JavaScript code, which uses the features from 1997. And you can't break the website, right? So what you have to do is extend the language. You can't actually do something in JavaScript which is not backward compatible. You can't force these people to actually update their old websites, which are still running. You know? So the web is alive. Which is why I have var and let. But ignoring, because in this example there's no difference, so it wouldn't be any difference if I used var or let. But ignoring this, the first question I might ask is, what do you think the second line will write? Right. So when I said var a, obviously I didn't put anything in a. What will the second line write? Well, let me tell you. So when I talk about a statically typed language, and I say I don't know something about a variable, right? What can I not know? Well, I can have a variable which contains a special value, which is called null, right? And null means I have a variable of a particular type, but it does not contain a reference to an area in memory where an object has been allocated. That's what null is. There's nothing in it. Well, in JavaScript, since I said that I can actually, I'm going to determine the type whenever I put something valid in a variable. That means I can have a variable for which I don't know any reference to a valid area in memory, nor do I know its type. Right? So in this case, var a, I don't know any object to fit this, nor do I know the type of a. And this is called undefined. Make sense? So a is undefined. Undefined functions in a bit of a special fashion in the sense that, again, in JavaScript, almost everything is concrete, which means that even this idea of undefined is a type with a single value. Right? It's something concrete. Now, a good bet in JavaScript is that if you don't have something explicitly defined, the answer is going to be undefined. It's explicitly undefined. So, for example, We're gonna see this. I'm a bit. All these things are in this presentation, but I'm mixing them a bit up. So, if I think about a function, how does a function work? Well, in other languages, I might look at it as an abstraction, but in JavaScript, I have a function prototype, and the value of evaluating the call of that prototype is the block that follows the function. Okay? So, what's the value of a function block? Something with a begin and an end. Well, it's the value it returns. Make sense? Right. So, what if it doesn't return anything? It actually returns undefined, because in JavaScript, everything is concrete. Right? So, it has to return something. What it returns is the special marker. Right? Something more interesting, though. Let's check that this happens, but I'm going to look at the commented line, because that's even more interesting. Right. So, undefined, etc. And I noticed that there are more undefined than I actually wrote. That's because console log, right? Console log returns something. But since it doesn't explicitly return anything, it returns undefined. Right? Console log, like any function, returns, it has to return. Right? But since there's no explicit return thing in console log, it's going to be undefined. Now, what about this one? Let's see what happens if we uncomment this console log B thing. We get an error. And it says B is not defined. What could have happened here? What's the difference between A and B? Well, let's get back a bit and think about what I said, that namespaces actually work like objects, right? And that namespaces, the representation is as a list of key value pairs. Think about it like a hash map. Now, if I think about it like a hash map, when I try to access A, what I have is, I have the key on the hash map, it just doesn't contain anything relevant. But when I try to access B, right, it's like accessing a non-existent key on any hash map. Right? It doesn't make sense. So that gives me an error. So A, the key exists in my namespace, although it contains undefined. B, the key doesn't exist. Make sense? Right, so subtle JavaScript adventures. But the point here is that everything is concrete, and that things that you might not think are represented as objects actually are. Right, so data types. Anyway, I said most of the first thing. So it has simple and complex data types, and if you look at the list of data types for another language, you're going to get pages and pages of things, right? Which tell you have something represented on that many bits, and something represented on another kind of bits, and so forth. Well, in JavaScript, all these things are simplified. Now, I'm going to lie a bit in the sense that there's one thing we're not going to talk about, but typically I have 3 simple types, which can be extended with 2 special types. So undefined is a special type, like I said, and null is a special type. It's a marker type. It's a type with a single value. But I have 3 simple types and 2 complex types. That's it. Like I said, bear with me here. There's actually 3 complex types, but we're going to ignore the 3rd one. Right, so I have string, number, and boolean. If they're written with a lowercase letter, that's the primitive type. If they're written with an uppercase letter, that's the object type wrapping the primitive type. The complex types are array and object. And like I said, we're going to pretend symbol doesn't exist yet. Because we have to talk about objects first, so we can, to talk a bit more in depth about objects, so that symbol makes any sense. Right. Right. So these are my primitive types: string, number, and boolean. We're going to go through them shortly. So, character strings. I can write character strings like we saw between single quotes or double quotes, but I can also write them between back quotes. Now, single quotes and double quotes, the whole thing with single quotes and double quotes is what is called syntactic sugar. Right? It's you could have solved that problem some other way, but you have a syntactic way of actually solving it more elegantly. Right? So you have a single quote in a text, and instead of writing an escape sequence like in C, you're just going to put it between double quotes and you're done. You don't have to worry about it. Now, JavaScript does support C-style escape sequences, right, with backslash. Of course. It's the advantage of my little renderer. Well, not that much. Maybe it's going to get better if I have time. Right, so I can do this. Now what about the third variant? Now the third variant, it's on the tilde character on the keyboard. It's backwards. Now backwards, yeah, it's under the escape. Yeah. And so they're called backwards. And the backwards actually allow me to do something else which is even more useful, which is they allow me to define template strings. Now template strings are also multi-line strings. Now what would this be about? Well, especially since I'm interacting with HTML, which I'm generating, when writing some HTML bits, I would want to keep things indented, right? I want to keep it readable. Now, I cannot then insert an enter within a string, neither in JavaScript nor in something else, within a regular string. I can't put an enter. I can put a new line, but that's something different. That's something which is going to happen when the code is run. But I want in my source code to keep things neatly organized. Let me just, I think I can show you this. No, I can't. I can. I don't think I can do this in the console, but anyway. So backward strings. So I could do something like HTML, right? And let's say I want to have the string to put it somewhere. It doesn't matter. It evaluates it instantly. I can actually put enters within it. But more interestingly, let's say we have a variable called a, and it says some content. And then this is a regular string. But I can do b is a template string, and within it I can define patterns. And the way to read this is whenever I get there, those are not just regular characters, the whole dollar, curly brace, etc., but it's rather an expression to be evaluated, which means b is going to be I have some content. Make sense? I can zoom in if you would like. Well, b. I have some content. Make sense? Right, so template strings are really useful. They're not a JavaScript specific thing. I can do this in Python as well. Now, obviously there are string objects. We're going to see next time. They have a bunch of methods. There's two, let's say, cultural epochs in JavaScript. So JavaScript initially was built on an approach which you could call everything but the kitchen sink, which means each of these types, their initial form, actually contains a bunch more functionality than you think about, such as you can iterate for the characters in a string. You can treat a string basically like an array, the string object. Now, in the modern JavaScript, so modern JavaScript is actually a standardized language. There's something which is called ECMAScript, which is the standard for JavaScript. You can implement your own JavaScript interpreter if you want, based on the standard, and it's going to be compatible. Now, the modern JavaScript actually is a lot more, let's say, enterprise friendly. Things are a lot more clearly defined. Right, now what about numbers? Well, numbers, this is another strange bit. So all numbers are floating point. This means you don't want to do stuff with JavaScript number types, which is based on financial data, for example, because floating point numbers have operations which are approximate. Right? They're lossy operations. I don't necessarily, depending on the binary representation, I'm not going to necessarily get a precise result. Now, obviously, though, I do have another representation for number, which is decimal-like, if you know what a decimal representation is. Remember BCD from first year? Right, so there's two variants of representing numbers. So I can represent them just in binary, or I can represent them digit by digit. And in any financial processing thing, I'm going to have a type which corresponds to BCD, which is digit by digit. Because if I don't do that, I'm going to have an upper limit to the values I can process. Whilst for BCD, you can represent no matter how large values. You can have numbers with 140 digits. Right, so if I have to do it like that, I can't use the number type. The number type is floating point. They can be written with or without the fractional part. JavaScript lies from time to time and tells you they're integers, but they're not. what the functions which contain int in them do is actually take a floating point number, discard the fractional part, and give you a floating point number. They never give you an integer. Obviously, they can be wrapped in objects, like I said. Now, this is the dynamic type. So if I look at the first line, via the simple fact that I put something into A is a variable which is of type number and contains a 5. But if I go a couple of lines under that, it's going to become a string. Now, the second bit that I told you about, which is I can actually redefine the type itself, is something which we're going to discuss further in the future. It's a bit more complicated, and it assumes we know how objects actually work. Right, so this is what I'd expect, type changes. Now, the third one is Boolean. There's a strange bit here as well. And the strange bit, so a Boolean value, Boolean things can only contain true and false, obviously. But there's the third, another strange thing here, which is, so a Boolean is something which I can use wherever I need the condition, right? So if I do if a Boolean value, that works, right? In the parentheses of an if. So I can evaluate, or I can have an expression which evaluates to either true or false. But in JavaScript, everything, when put in a Boolean context, can evaluate to true or false. So any element of the language is either true or false. This is called truthiness. Truth-like, the truth-like. So the idea is this: I have truthy and falsy values. Falsy values are a limited list, so they're false. I forgot to translate that. So the way it's the empty string. It's the number 0 and minus 0. There's two of them because we're in a signed floating point representation. Right, undefined null and not a number. Now, most of these should be familiar. What is not a number? Well, not a number is a special value. It's actually represented as a number, which represents the fact that the result of a numeric operation gave me a result which can't be represented as a number. Right? Under which circumstances can this happen? Well, it can happen if I do a conversion. Right? So the conversion to number of the word giraffe isn't something I can name as a number. It's not a number. And it can also happen, but this depends on the language, when I have overflows. So on any kind of limited size representation, I can think on an operation which is going to exceed that size. Right, so if I think of the representation on one digit of the digits from 0 to 9, if I add 9 to 9, it gives me something for which the result cannot be represented on one digit. Make sense? Right. Okay, so that's not a number. There's a function for this. It's called isNotANumber, which allows me to check if the result of my operation was a number or not a number. Now these are simple tests of the truthiness bit. You can actually run them, but for now let's go over them and get to the complex types. So I said I have two complex types. Even here, things are a bit stranger in the sense that arrays are actually objects. They just have a special representation. I can see that they're objects, right? So the brands bit, right, is an array literal. It's really comfortable to instantiate arrays like that, obviously. I mean, it's really useful. Instead of doing the other bit, right, in which I call a constructor explicitly. But notice, since it's the first time we saw a constructor, that this sort of looks like other languages, right? It's new and some type, apparently. Right, so I said that there's two say, cultural approaches. And in the initial cultural approach, arrays are many things at the same time. Comically enough, they're not arrays. Because if you talk about other languages, what would an array be? What would be the definition of an array? A pointer? Maybe. Yes, but it's a bit extreme. It's a contiguous area of memory, right? Which is of the size of the array, in which you have element after element, right? It's a contiguous thing. Now, JavaScript arrays are not arrays; they're lists, so they're not in a contiguous area of memory. They're lists of objects always. Now, what a list would be I have a data structure which allows me to have positional access. Right? It's an array list. Now, but like I said, it's the everything but the kitchen sink approach, which means that my arrays are actually also queues and they're also stacks at the same time. Now, if I think about this, this is something. If I want to have this array list, which are also queues and stacks, what I have to have is for queues, I have to be able to add elements on one side and take out elements on the other side. And for stacks, I have to be able to add elements on one side and take elements on the same side. Make sense? Right. So JavaScript arrays actually have 4 methods, which allow me to add and remove to the left, add and remove to the right. Left is shift unshift, right is push pop. Well, shift is remove, so it's the equivalent of pop, and unshift is add to the left, and it's the equivalent of push. So if I take my array and imagine rotating it in space, right? It can be a queue, a stack, whatever I want. So there's this kind of overloading of data structures in the initial representation of JavaScript. Now arrays have a more modern interface, which we're going to talk about next time, which contains higher order functions. You've met higher order functions in other languages, so map, reduce, filter, etc. Now, what about objects? Now, I said that JavaScript is not a classic language. What does that mean? Right? So, if I think about, to give you a metaphor, it's if I think about objects in Java or in C#, whenever I want to build a chair, I have a design document for a chair, right? I have some sort of schema for the chair, and based on that, I'm going to look at the plan, right, and build my chair. So that's how a classic language works. There's an abstract definition of the type. Now, but let's think about it like this. So, what is the type? Well, the type actually defines what is common between all the objects which are in that type. Make sense? That's the role of the type. It defines what's common between them. They're all cats, or they're all giraffes, or whatever. Now, in JavaScript, it doesn't work like that. I don't have this abstract definition, and remember that I said that JavaScript is concrete in most cases. So, in JavaScript, to take the same metaphor, instead of having a general plan, an abstract plan for a chair, what I have is an actual chair. And when I try to create another chair, I go to somebody and I tell them, build something just like this. Right? So that's a prototype. JavaScript is a prototype-based language in the sense that what's common between all the objects of the same type is a concrete object instead of an abstract definition. Make sense? Right. Now, this prototype is actually something for which I can get a reference. Right? I can actually say something, and I can get the prototype. I can access the prototype. And because I can modify the prototype at runtime, I get that other side of dynamic typing, that I can modify types. Right. Now, there's one of the fundamental characteristics of an object-oriented approach is that I can have inheritance. I can have inheritance in JavaScript as well. But the way it works is a bit different. It's a prototype chain. Now, let's get back to our namespace discussion earlier on. What happens if I don't find something on the namespace? Do I give an error immediately? Probably not. What I do is if I don't find something on my current namespace, I'm going to look on the containing namespace, right? I'm going to look on my parent namespace, and then on that parent and so forth. And if I run out of these, then I'm going to give an error. Make sense? So I can talk about something like a namespace chain. Right? I can order them, and I can actually explain how this goes. Now, something similar happens to objectual inheritance, and there's a prototype chain. So if on an object I don't find a particular key, I'm going to look on the prototype of that object, and then on its prototype and so forth. Now, this whole object chain is going to finish, at the top, is going to finish with something which is the generic representation of an object type object. Now, another thing is I said that objects are serializable in JSON, and this serialization business is something which is fundamental to the language. So it's not something which you might do in some specific situation, right? It's not, you don't have to mark an object as being serializable. No, everything is assumed to be serializable because you're in a browser on the web, right? It's not, you're not writing error correction algorithms. You're writing stuff which transfers objects over the web. Right, so you have two global functions which are json.stringify, which takes an object and gives you the string representation, and json.parse, which takes a string and gives you the object. So it's really simple to do. Now, objects behave similarly to hash tables. That makes sense if you think about what we talked about earlier. That is, objects are list value pairs. Some of the values are characteristics. Some of the values are behavior. Right? So some of them are, say, numbers, and some of them are functions. I ate a C. I'm going to correct this. Right, so objects can be defined in two fashions. So the first thing you see there looks very much like a hash table, and it's an object literal. Right, it's a thing which I can put in an object variable. The second bit is I run a constructor. What does a constructor do? In general. Yes, no, no. New creates the object. Yeah, it runs itself over that area in order to initialize the object. Right? So that's what's happening here. Now we're going to see that we have some syntactic sugar which uses the keyword class, but that's not going to mean that JavaScript has classes. It's a bit more confusing. We're going to see when we get to that. But to define an object type in JavaScript, what I actually have to do is define the constructor. That's all I need, right? So to make a valid object, what I can do is run the constructor over a memory area which has been allocated. Now, something which I haven't mentioned. I keep allocating stuff, right? But I'm not deallocating anything, which tells me that the language is garbage collected, right? Which means I don't have to explicitly deallocate anything. You've run into languages like this before. Now, but what's the trade-off for garbage collection? Do you know? What do I lose? Why do I want managed memory? Well, what I lose is predictability, right? So I don't know when the garbage collector is going to collect something, which means it might happen at any time. So if I have software which is real time, which means I have to be able to predict how much something is going to take exactly, right? I write software for a pacemaker. Right? So if the pacemaker garbage collects, we're going to kill somebody, obviously. So basically you have two large categories of languages, right? So you have application-focused languages, such as this one, which can be garbage collected, and then you have system-focused languages, such as C, where you can actually predict what any piece of how long any piece of code is going to take exactly, how many processor cycles it's going to take. Although generally you're not going to do that, but it's going to allow you to do that. Anyway, right. So this is some object serialization. The second and third parameter allows me to print it in a pretty fashion, right? So the third parameter tells me what the. So obviously when I serialize something, I don't necessarily care about the graphical representation. But if I do, such as here, I can specify a tab size of 2. Right, so it looks pretty. Right, functions and methods. Now we're going to go deeper for this in the next episode. But for now, let's look at that function declaration. Right. Again, if I relate this to the languages we've already learned, well, it doesn't necessarily look all that strange. In the sense that I'm in a dynamic language. Since I'm in a dynamic language, my function prototype isn't going to specify a return type. So I need a keyword, because if I don't use a keyword to define functions, I'm not going to be able to distinguish between declaring and calling a function. The interpreter is not going to be able is going to mix them up. So if you look at Python, you have def. If you look at other languages, you have fn. It doesn't matter what the keyword is, but I have to have something, and in this case, it's function. Now then it's a function name, the list of parameters, and like I said, when I evaluate this, I'm going to have that block. What does this particular function return? What does it return? Undefined, yeah. in order to return something other than undefined, it should have an explicit return. It should say return something, because the keyword is the same. Right, but let's look at something a bit stranger. I said some functions are values, so I can do something like this. Let f1 is f. Right? So then f1 is going to contain that function, so I can call it. Now something else. So I have my object, O, and I said I can modify it at runtime. So I can say O.do stuff, which is a key in the object, is going to be my function. Okay? I can call it on the object. Let's look at this in action as well. Right? So it's called all the time. However, I'm lying a bit. Because, like I said, what's the difference between a method and a function? It's that the method knows who this is. Right? So in this case, it's going to work out fine. However, when I do something like object.do stuff is a function that doesn't know who this is. It's not, it's not bound to that particular object. I can bind it, but it's not going to work like this. This is going to work out because my function doesn't access anything. My function writes some string on the console. See, it doesn't use this. It doesn't matter if it knows who this is because it doesn't use this. So it works so fine. But if I want to bind a function to an object and transform it into a method, I can do that in the language, and we're going to see this somewhere further on. Special data types, like I said, null represents the idea that I have a variable with a defined type for which, though, I do not know an actual reference. Undefined represents a variable which has no defined type, and therefore no defined values. Now, type comparisons. This is another strange thing we have to talk about. Now, generally speaking, when I think about JavaScript operators, they're going to be similar to the operators you'd find in C. Right? They're going to have similar precedence. I'm going to have some additional operators, but some of them, okay, they don't exist in C, but I wouldn't be surprised if they exist. For example, this one. So it's 2 to the 4th power. Well, this one, I don't have this operator in C, but if I did have, right, it would fit right in. It's something for which an actual machine, hardware machine instruction exists. Right, so what else? Well, obviously JavaScript is not C, although it has this, this C similar syntax. So I have some other operators which I'm going to need for the additional features, such as object instance of type. Right? It's going to give me true if it's an instance of that type, although it doesn't mean the same thing. What else? I have hash tables, so I probably have an in operator, right? So key in hash table. It tells me true if the key exists. However, this is going to be a bit stranger. This is something JavaScript specific. So I have A, and A is 5, the number, and B, and B is 5, the string. Right? Now, what would happen if I try to do the third line in another language? It will give me an error. Because then it's not that they're not equal, it's that they're not comparable. How do I compare a string to a number? However, in JavaScript, this is going to give me true. That's because JavaScript is really, really passionate about implicit conversions. So if it can make something work, it's going to make it work. However, that may not be what you imagined would happen. Right? So in this case, 5 and 5, 5 the number and 5 the string are double equal. For this reason, we prefer to use triple equal, which can be read as they are equal and have the same type. So I can actually have comparable stuff. Make sense? Right. Now, by the way, how does the first comparison work? How do you think it would work?
The first comparison already compares the values, while the triple equal also.
What type of values does it compare?
Implicitly converted.
To string. Right. It converts everything to string,
Yeah.
enthusiastically, and then the strings are equal. Right. So that's something special. Anyway, I have some explicit conversions. There's a bunch of them here. We're not going to go through them. This is another interesting thing. There's a function called parseInt, which returns something which is not an int. Like I said, there are no ints, which means it's going to, if I do parseInt of 5.2, if I do parseInt of giraffe, it's going to give me not a number. If I do parseInt of 5.2, it's going to give me 5, but it's actually 5.0. Right? It can't return an int. Auto-boxing, we talked about this. So I have a primitive string, and I call a method on it, and it actually works. This works in many other languages, because what's going to happen is a string object is going to be created around it, and the method is going to be called on that object. Well, so I have a plus operator, and the plus operator, like in many other languages, is overloaded, which means it works on numbers, but it also works on strings, right? So if I put a plus between two strings, it concatenates the strings. If I put a plus between two numbers, it adds the numbers. But what happens if I put a plus between a number and a string and a number, sorry. It's going to give me a string, again for this conversion enthusiasm. What about a string and an object? We don't need to know the type. Well, I said that there's an object hierarchy, right, inheritance-like, and that at the top there's an object type, the object, and that one has something which is common between all objects, and that is a toString method, which means that if I do a string plus an object, I'm going to have a string plus the toString of the object. Right, so everything works like this. When I print an object to the console, it's going to be the string of the object. Now I have a bunch of operators here. Most of them are not really all that interesting. Let's just look at them. I have modulo. I have attribution with division, all that jazz. All right. I have bitwise operators. Right. What else? So I have type of. So type of will give me the type of a variable. I have unary plus. What's unary plus? Well, it does something like this. It does inline conversion. So if I do this, it's going to give me the number 5, sorry. I have delete. Well, since I have hash tables everywhere, delete is going to, I can delete elements from an array in a variety of fashions. But to delete something, to delete a key from a hash map, I need a delete operator, right? So just delete the key. And the other thing is not really all that relevant. Since I have hash maps everywhere, again, I have to have an in operator. So I can check if a key is on a hash map. We saw that if I try to access a non-existent key, I'm not going to get the results I imagined. Now, instance of does something a bit different, especially since there are no instances, basically. Since I have prototype inheritance. So what it does is it tells me if object is somewhere in the prototype string of some string. Because I said that any object has a reference to its prototype, which has a reference to its prototype, and so forth. And when I look for a value on an object, I'm then going to look on the prototype and the prototype's prototype until I run into null. So instance of tells me if the second thing is in the prototype chain of the first thing. And the last thing, and I think we're going to stop here, is the spread operator. Now the spread operator works on arrays and on objects, and it does destructuring. Now think about it like this. Look at the third line. If I said C is an array of A and B, C would have been an array of arrays, right? The first element would have been the 1, 2, 3 array, and the second would have been 4, 5. Well, destructuring actually takes out one dimension. So destructuring a matrix gives you a vector, destructuring a vector gives you values, and so forth. So in this case, since I'm destructuring A and B, what I'm going to get in C is 1, 2, 3, 4, 5. And I think this is it. We're going to continue with flow control next time. If you have any questions, I'm going to stop the recording.